Welcome everyone to today's episode. In today's episode, we will learn how to perform mosaics using Rasterio. And I have two data sets from Copernicus. They are DEMs. I renamed them to A and B for clarity. It doesn't only work for DEMs, it works for all raster files. And I have QGIS here so we can visualize the two rasters, A and B. And if I bring this one down, I intentionally chose them that they will overlap and have different sizes also here. Your own doesn't need to be this way. It will still work. This is just for demonstration. So I'll remove these ones for now. And I also have the Rasterio documentation open because I will show you some extra things you can do when you are performing the mosaic. And the best place is the documentation. So let's come back to VS Code and then let's start with our imports. We will need OS, so import OS. We also need glob and Rasterio itself, which we will import as real. And then from rasterio.merge, we want to import merge. And these are all the imports we need. The next one is for us to maybe declare some directories, read the band or something like that. So let's just say declare directories and read files. Here we will first declare our data directory, which is os.path.join. If we join the current working directory to data, we will have our data directory. And we can repeat the same for the output also. We just have to change this data to output. And the file that we will save later on is, let's call it merged file or mosaic. You can choose any name which you think is appropriate. So merge file, that should be equal to os.path.join. We want to join the output directory with a file called mosaic.tif. And now we read the files. Files, let me give a comment here. Read the files. Files will be a list, or you can also, for now, let's just get all the actual path names, so file paths themselves, which you can do by glob.glob, and you pass os.path.join. We join the data directory with start.tif because that's the extension is TIFF. If you check from the data, see that it's a .tif file. So this line will get us all the files in the data directory that ends in .tif, because you see that there are some other files that get created when we visualize our raster, these XML files. We don't want those ones in the computation. Now then we can see src files, which may be source files. You can give any other name you want. That is real.open, and then we will open file for file in files. Now, if you are not really okay with the list comprehension, this might be a bit confusing to you. how we are fetching the src files. So you can also say src files equal to an empty list first. Then now you loop through every file in files, and then you append it to the src files list. Real.open and then file. So this here is the extended version of this, and I always recommend that you use a comprehension wherever and whenever you can. But if you're okay with this one too, then fine. So I'll comment this one out and leave it there, but I will use the comprehension. So let me run this. No error, so all is well. And the next one is to perform the mosaic itself. Here we will now consult the Rasterio documentation. So the method we are using is merge. We want the module. If we scroll down a bit, you see that we have merge.merge. That is what we are using because we imported it. We imported merge from rasterio.merge. If we skip this part, which may look a bit confusing at first, and come down, is the same thing, parameters that have been listed here in a more beautiful manner, let me say so. So there's the sources, which is the list of data sets opened in R mode. So the ones that we opened as source files. And there are other optional arguments you can pass. That is what I wanted to show you, which is the bounds, resolution, and all of them, resampling. They all have their defaults or none. So depending on your use case, your need, you may need to adjust these parameters to fit purpose. But I will leave all of them as default, and then for the sake of the tutorial, but I just wanted to show you that this is there in case you need to extend functionality. Here, also, it is important. We know that it returns two elements, which one is a NumPy n-dimensional array, and the other is the affine, the transformation. So let's come to VS Code. We know that we are anticipating two things. The first one, which is the NumPy ND array, we'll call it mosaic. You can choose any other name that you like. And the transformation, I'll call it output transform, which should be equal to merge. And then in here, I can pass the src files, because I'm taking default for all the rest. And this one will give us the mosaic, but we need to also save it. And with that, we need to update the metadata, because now the two rasters will come together and will have a different bounding box, different from the first and the second one that we are combining. In your case, maybe if you are combining 6, 7, 8, 20 files, now they will have a bounding box that covers all of them. So of course, some parts of the metadata will change, and so let's update that. But before we do that, let's even get a metadata from one of the raster files we opened. That will be meta equal to src files. We just pick the first one, because my files are all in the same coordinate reference system, which is an important pre-processing step. If they are not in the same coordinate reference system, then you will want to reproject them. I've made videos that shows how to do that. You can look through the playlist, they are there. And then here we get the meta.copy. If we print this meta, yes, now it works. So one of the few things that will change will be the width, the height, and the transformation. The transformation parameters will also change. So meta.update And then we can update first the transform, which will be equal to our new output transformation. And then the height, which will now be equal to mosaic, which is our array dot shape. And then we pick the second element. And then we do so for the width as well, which is also mosaic dot shape. And then we pick the third element. But if you're wondering why I am picking second and third elements, remember we saw in the documentation that it returns a NumPy n-dimensional array. So what happens is that this particular array we have here comes in the format of number of bands, which of course is the n, and then we have height and then width. So that is why I'm assessing the width and height in this particular manner. So if I wanted to get the number of bands that are coming out, I can use the mosaic.shape 0. But that is not of interest now. Now that we have updated our metadata, what we can do is now to save the file, which is with rio.open. And then remember we created a merged file path up there. We make sure that we tell it that we are writing, and we spread our metadata. We are opening it as DST. You can choose any other name, and then DST.write. We write the mosaic. Of course, you can set band descriptions and other things you find appropriate, but I've already covered those ones in previous videos. This is just to show how to do mosaics. So now in our output folder, there is nothing. If I refresh, there's still nothing. But as soon as we run this cell and we have an error here, of course, this is a typo. It's supposed to be update. And then I run again. This time around, no error. And you see that there is an output file here called mosaic.tif. We can come to QGIS here. It's already there. And we drop it in, and you see that we have a mosaic of the two rasters. Like that. Okay. And this, of course, is the no data part because one was smaller than the other. That, my friends, is how we perform mosaics using Python. If you have any questions or concerns, you can leave them in the comments and I will reply them as soon as I can. As always, the link to the code, the GitHub repository will be in the description below. If you like the video, please give it a thumbs up and don't forget to recommend it to your friends who you think might benefit from it also. Thank you very much for staying up to this time, and until next time, it is goodbye.